All right, guys, good evening once again. We're going to be continuing from where we left off. The last thing that we were looking at from previous class, we were looking at how to factorize quadratic based on those that have coefficient in front of the x squared. And so we know that we are using a slight different technique from the one that we were using when the coefficient of x squared is equal to 1. So I'm just going to just review the example we last looked at, and then we're going to go right straight to the question that you were doing, and then we're going to go through those questions together. All right. So case 2 that we have started looking at from last class for the quadratic is when coefficient of x squared is not equal to 1. So when it is not equal to 1, it means that the coefficient can either be greater than 1 or it can either be less than 1. So here in the general form, the coefficient of x squared would be a. So what this means, a can be a value greater than 1, or a can be a value less than 1. So in terms of the steps factorizing this form or this case of the quadratic expression, what we generally do, we find the value of a times c. And then now, after we find the value of a times c, then we now search for two factors that can go into that product, AC. When we add them, we get the coefficient of b. And so just like before, we replace the middle term with those two factors in terms of x. And then now we factorize by grouping. All right, so we are just going to just go through these steps, look at the example once more, and then we're going to jump right into the questions. All right, so step 1, find two factors of AC. And the two factors we are looking for when we add them should give this the sum of b. All right, so that's step 1. Step 2 now, we're going to now, we're now going to apply what we know to this example. So in order to factorize this example, first step is to find AC, which is 12 times 15. And so 12 times 15 here will give us, and not just 12 times 15, but 12 times negative 15. That will give us negative 180. All right, so we need now to find two factors of negative 180. When we add them, we get 11. So we would have explored all the various combinations of these factors that we can multiply to get 180. And the pair that seems to work, or the pair that works, I should say, would be, because we want to get a positive 11, then we would choose the pair positive 20 and negative 9. Because when we subtract 9 from 20, we get 11. When we multiply negative 9 by 20, we get negative 180. All right, so those are the two factors that we'll be substituting in the expression, writing them in terms of x. So we would have 20x minus 9x. So we're going to replace the 11x with that 20x minus 9x. So we're going to just remove the 11x and then we put 20x minus 9x. So that gives us a quadratic, well, that gives us a 4-term expression. And this is where the name of this expression actually comes from. Because when we actually find two factors and replace those two factors for the middle term, you notice we end up with 4-term. And you know, if you know anything about prefix, anything that deals with quad would actually be 4. So this would be a 4-term expression when it is rewritten in this way. But normally the quadratic expression would have present themselves in a trinomial form. All right. And so once you make that once you actually carrying out the process of factorization, then following these steps, you notice that it becomes now a 4-term expression. All right, so factorizing by grouping, we choose the pairs of common factors. And here we would have seen for the first pair, we see that the common factor here, a number that can go into 4 and 12, the highest number into 4 and 12 would simply be 4. And for the common factor x, we choose the lowest power of the x to be the HCF. So in other words, the HCF for those two terms would actually be 4x. And so following the general rule of factorization by HCF, what we do, we divide each of these terms, we open brackets, and then whatever we get from dividing each term, keeping the sign that we have between them. So we say 12x squared divided by 4x. That would simply give us 3x. And now we would say 20x divided by 4x. 4 into 20 goes 5 times, x cancel, give us just 5. Now if we look at the next pair, we see that the common factor here, the highest number that can go into 9 and 15. And just to be a little bit more specific, because these are negative, we are going to use the common factor to be negative. So we use -3 as the highest number, that is numerically the highest number that can go into -9 and -15. So we divide -9 by -3, we get -9x by -3, we get positive 3x in the bracket. We divide -15 by -3, we get positive 5. Now, when we examine both brackets, we're supposed to have the same expression in both brackets if we are to factorize any further. If the expressions are not the same, it means one out of two things. It means that we cannot go any further, or we just need to go back and rearrange what we have with the expression to see whether or not we could find pairs that might give us the expression in brackets the same after we factorize them. All right. So that's pretty much what we did. Now the expression in brackets is now the HCF because it is common in both terms. So what we're going to do now is just choose this expression in bracket as our HCF. And so we divide each term by x plus x, 3x squared plus 5. We notice that we have 4x from this term, and we have -3 from this term. So both of those we would put in the second bracket here. And that is where we would have ended our factorization. All right, so this is where we would have left off from previous class. We started doing some of these questions before going off. So I'm just going to ask, just to simply finish up these questions, and then now I'll give you about 5 minutes, then we can go through them. Each person prepared to walk me through one of these questions when they're back. All right, guys? So you may go ahead now and start these questions. All right, so I think by now we should probably be on our way in completing these. So I would have gone through the first two questions from previous class, but just to give a little bit more reinforcement for those who were not here. Anybody would like to walk me through question one?
Sir, I'll try.
Go ahead, Mr. Williams.
Okay, sir. So not question one, sir. It's number 3. We did 2, 1 and 2 already. So I'm working number 3.
No, we're going back from question one for the sake of those who were not here. So that's what I was saying.
I didn't work question 1 and 2.
If you're not prepared to work question one, just give somebody else a chance to do it. All right.
Okay, sir. Okay, sir.
All right. So is there anybody else who'd like to do question one? All right, Miss Cummings, are you there? I'm not sure. You seem to be answering, but I'm not hearing anything from my end. I'm not sure what is happening. You want to check your mic or something? Miss Genovia, are you there? All right, let me see the answer those who are actually hearing me, because I'm not sure. It seems like some persons are not hearing me. All right. All right, so Mr. Ojeno. Mr. Ojeno?
Yes, sir.
Yeah, would you like to walk us through question one?
Okay.
All right. Okay.
Question one. Question one is 2x squared minus 7x plus 5.
Mm-hmm.
So first thing you're going to do, you're going to find the AC.
All right.
And
So,
the AC is 2x. 2 times 5. That would give 10.
so AC give you 2 times 5. Equal to 10.
Yeah.
All right. So how does that help us now?
All right. And you're going to find the factors of 10.
Okay.
The
So go ahead.
factors of 10 going to be 2 and 5.
All right. 2 under 5.
So you're going to have 2x squared.
All right. Before you actually give me the x's, can you tell me what sign the 2 under 5 should have?
Minus.
Okay. All right, so here we will have minus 2, minus 5. So what will you get now?
So you're going to have 2x squared.
All right, so negative 2x.
Yeah, negative 2x and
All right.
negative 5x.
All right, so you're writing the entire expression. That's what you're doing, right?
Yes, sir.
And you're replacing the 7x.
Yes, sir.
All right, so walk me through.
Sir,
Yes?
so the negative 2 and the negative 5 come from?
All right. I'll just ask Mr. Ojeno to explain that to you. Mr. Ojeno?
Yes, sir.
Can you explain the -2 and the -5? Was that Ms. Cox?
Yes, sir.
All right. Can you explain that for Ms. Cox?
When B is negative, both factors are remain negative.
All right. Stick up in, Mr. Audrina. Ms. Cox, were you here on Tuesday?
No, sir.
Okay, all right. Were you here the previous class before Tuesday?
Yes, sir.
All right. So it's the same principle that we're following from that time when we say we need two. You remember when we're doing the first set, we said we would need two factors of the last term. When we add them, we get the middle term.
Yes, sir.
It's the same principle. But now in this one, because the coefficient of the x squared is greater than 1, we, instead of finding two factors of the last term, 5, we are now finding two factors of the product of the coefficient of the first and the last term. So we multiply the 2 times 5 to give us 10. So now what we're looking for is two factors of 10. When we multiply them, we get 10, and when we add them, we get -7, right? So I would have mentioned some analysis that you can use the sign to determine what these signs are. All right, but when you think about it, which two numbers you could use to multiply to give you a +10, and when you add them, you get -7? Ms. Cox. So would you notice here that if we use -5, -2 times -5 and multiply them, we will get what? +10. You agree with that? Ms. Cox?
Yes, sir.
Are you following?
Yes, sir.
So we are saying that if you should use +2 times +5, you get +10. But if you add +2 plus +5, you would not get -7. We want, when we add the two numbers, we get -7. So we could now try -2 times -5, we still will get the +10. If we add -2 plus -5, now we will get the -7. Hence the reason why we are using negative here. Is that clear?
Yes, sir.
Right. So so with that said, Mr. Ojeno, can you continue? Are you still there, Mr. Ojeno?
Yes, sir. So we're gonna rewrite the expression.
So we start off with 2x squared.
2x squared minus 2x.
All right, so we're replacing the -7x in terms of -2x and -5x. So we're just taking out the -7x, replace it with -2x and -5x. So we see when we add -2x and -5x, it is the equivalent to -7x. So we can just take out the 7x, replace it with those two numbers that give you the same sum. And then now, by doing that, we put back the 5, and now we have a 4-term expression. So this now would be able to factorize by group. Okay, Mr. Ojeno, continue.
All right, so we are group. So group them in, no, sir. So we're going to group the 2x squared minus 2x.
Okay.
And the highest common factor going to be 2x.
All right.
So 2x into 2x squares goes x. Leave you with x. And 2x into 2x leave you with 1.
All right. Now don't overlook the sign, because sometimes when we overlook the sign, we tend to multiply them and get the wrong sign. All right. So please just pay particular attention to the sign. All right, I think I'm always having challenge with this thing. Anyways, continue, Mr. Ajeno.
All right, so you're going to factorize the next set. So the highest common factor for that set is going to be 5.
All right, so for this pair, the common factor would be 5. Will you use positive 5 or negative 5?
Negative 5.
Okay. Do you want to explain why you're using negative 5?
No, so I remember just know what's up using.
All right, so if you notice here though, if you divide through by positive, what would you actually get in the bracket? If you use a positive 5, just notice what will happen. So negative 5x divided by positive 5, what would you get for the x? Divided by positive give you what? Don't remember. Negative 5x divided by positive 5. 5 cancel. The negative going to remain. Negative x. You see, Mr.
Negative x.
Right. So by dividing by negative x, this x would be negative. Sorry, by dividing by positive, this x would be negative, and then now this is positive. And what you'd notice with the expression, would they be the same?
No.
No. And so in order to get them to be the same, that's why we are now using the negative 5, because we know that when we divide negative by negative, we get what? What sign we get?
Positive.
Positive. Right, so the negative 5 cancel the negative 5, give you a positive x.
Positive x.
Right. And then next?
Negative 5 divided by negative 5, and leave you with.
So positive 5 divided by negative 5 will give you, positive divided by negative give you what? Positive or negative?
Negative.
Negative, so that will give you negative 1. All right, now when we look at both bracketed expressions, we have what? X minus 1, and that's what we want the two expressions to be. All right. If these two expressions are not the same, then it is not likely for us to go any further in factorizing, because we have to pull out one of these as common factor.